Genevieve speaking. In this presentation, we use the Martin closing store problem from our text and show how to use the binomial probability function in Excel to solve that problem. First, we look at the definition of binomial experiment. So a binomial experiment consists of a sequence of n identical and independent trials, each with two outcomes: success with probability p and failure with probability 1 minus p. Next, we want to show that the Martin closing store problem is a binomial experiment. In the version of the Martin closing store problem we're looking at, the manager forecasts 10 customers to enter the store in the next hour, and the manager estimates that the probability that any one customer will make a purchase is 0.30. So we are looking at a binomial experiment involving the sequence of decisions made by 10 customers to purchase or not. It is a sequence of 10 identical trials, one trial or purchase decision for each of the 10 customers that will enter the store in the next hour. Two outcomes: the customer makes a purchase or the customer does not make a purchase. So two outcomes are possible for each trial. The probability that the customer will make a purchase or will not make a purchase is identical for all customers or all trials. And finally, the purchase decision of each customer is independent of the decisions of the other customers. So all the properties of a binomial experiment are present. So we can use the binomial probability function to compute probabilities of interest to us. To make things easier, we're going to use the Excel built-in binomial probability function. As explained in your Appendix E in your text, you can select the Formula tab on your worksheet to figure out what functions are available to accomplish a task or how to use a specific function. Alternatively, you can go to the Microsoft Office support page. So we want to go to Excel, formulas and function, and then functions. I am on the function page, so I want to look at all the functions alphabetically. I can scroll down, and I'm looking for binomial. Here it is. A little further down. That's the one I want. Okay, so here on this page we are going to find instructions on how to use this function. So here's a copy of the instruction on how to use this binomial distribution function from the Excel support page. The arguments of the function include number s, trials, probability s, and cumulative. They all correspond to information we'll need to specify into Excel. First, the number of successes in trials. So we know that 10 customers will enter the store in the next hour, and that the probability that any one customer will make a purchase is 0.30. For our specific version of the Martin closing store problem, here we're going to ask, what is the probability that 5 of the next 10 customers will make a purchase? So in this case, the number of successes in trial would be 5. In our binomial probability function, number s in Excel was specified here as our variable x. So number s in Excel for number of successes and variable x in the way we specify a binomial probability function in our lecture note and in the text. So here x equals 5. Next, the number of independent trials. Here we're looking at the manager expecting 10 customers to enter the store in the next hour, so the number of trials would be 10. Number of trials 10. Earlier we specified that as n, just like in the algebraic expression of our binomial distribution function. The third argument is probability of success in each trial, and the probability of success we said was 0.30, presented as p earlier in our binomial experiment, the way we just specified it. P is the notation that was used also in our algebraic expression of the binomial probability function. The last argument is cumulative. So the instructions tell us that it is the logical value that determines the form of the function. So if we want to use this Excel function to compute the cumulative probability that there are at most 5 customers that will make a purchase, then we will specify cumulative as true. But here we're saying that we're interested in the non-cumulative probability that exactly 5 customers will make a purchase. So then we'll need to specify cumulative as false. So we're ready to use the binom.dist Excel function to solve our problem. So this is a template, and then we can reuse that template for other problems. So we have a list of the arguments or information we need to give Excel. And so we are interested in the probability that 5 customers will make a purchase. Oh, the number of success is 5, or x is 5. So 5 customers among the 10 customers that the manager expect to enter the store in the next hour. So the number of trials, or n, is 10. And the manager estimates that the probability that any one customer will make a purchase is 0.30. So probability of success, or of one success, or p is 0.30. And finally, we're interested in the non-cumulative probability that exactly 5 customers will make a purchase. So we say no, it's not a cumulative by typing false. And then we go down below and call up our norm_dist function. We call it up by typing. First typing the equal sign, then norm.dist, and then we instruct Excel to go get the value for x in cell B1, go get the value for n. Oh, I used the wrong distribution. I want the binomial. Binom_dist. Here we go. All right. Number of success. Get it from B1, trials from B2, probability S of success from B3, and value for the argument cumulative specified in cell B4. Okay, and close the parenthesis, and there we go. So when the probability that any one customer will make a purchase is 0.30, the probability that 5 of the next customer will make a purchase is 0.10. The advantage of having this template is that I can change the value of one of my arguments above, and then I have a new value for my probability down below right away. So let's say that the probability of success is 0.4 instead. Okay, so I'm changing that. Then I get that the probability, when the probability that any one customer will make a purchase is 0.4, the probability that 5 of the next 10 customer will make a purchase is 0.20. And this concludes our presentation of the binomial probability function in Excel using the Martin closing store problem from our text.